So my talk today is about availability. If you ever run any survey of any kind, you would have an availability metric on your team. It's one of the fundamental metrics that pretty much every service that we run has. Over time, people have started to build more and more reliable systems. We typically measure them in terms of nines. People can say, I have a 3-9 system or a 5-9 system, and people can keep going crazy and say 9 nines and keep adding nines. It's all well and good. In general, I'm a big fan of improving reliability, adding more nines to your system, but availability is beyond just nines. It's pretty easy and straightforward to measure availability for your service at the service level, but when you build a product in the modern era, it's never about a simple service. It's usually a complex system with a number of services that make up the entire product. Each one of them might be working well. If one critical part of the system is not working well, then the entire product may not work the way it works. So your 5 services might be running at 4 or 5 nines, but if one of the critical systems is not working well, the end users might run into problems that you wouldn't want them to run into. So looking at a holistic view of availability, how it applies to users, is an important part of building a good product. As much as I talk about nines, not obsessing with nines, it doesn't change how we work. This is a t-shirt my team made recently. It talks about how the team is adding nines since 2009. That's when Bing launched. Incidentally, this is the 10th year for us. Still a big fan of nines, so it was a nice little gift from my team on this. One note here, for the event, in the last year, the t-shirts when we had made unisex t-shirts. And this year when we made shirts that covered male and female t-shirts, that actually got a lot more positive feedback, because the t-shirts that were unisex, generally the sizes tend to be larger, it really didn't work. So that's something that was a positive outcome of even doing something like this. Let's start with a real-world example. Any Firefox users here? Good. Yeah, I use Firefox too, one of many browsers I use. I use this example for a few reasons. There have been outages in the world. On Microsoft, you've had issues in Office, Azure, Bing, and if you look at Google, it had a recent outage. Facebook has had its fair share of outages. Any large system you have has outages. I chose this one for 2 reasons. One, it's a recent one. This happened last month. And second, it's not a typical cloud service we think of. When you think of a browser, typically we think, oh, it's a client that's running on my machine. Things just work. In this particular case, I have a link for the entire postmortem from the team at Firefox. It's written by Eric, the CTO on the team. And it's a very good postmortem that details how complex the problem was and how they were able to address it. A couple of things that stood out for me in this particular incident. One was that users who were using Firefox, if they're just trying to go to YouTube or a specific website, that basic functionality worked. But if they're using any add-ons, which almost every Firefox user does, those add-ins weren't working. This lasted a few hours, which was not a great thing. And the issue was not on the server side. On the server side, the code was all working fine. If they had any APIs that the clients were calling, they were all working fine. It just happened so that there was a certificate that had expired that led the add-ins to not work properly. I mean, I've had my fair share of incidents from certificate management. That's one of the things I really don't want to deal with, but it's a complex problem. When you think of availability for a product like Firefox, how do you even measure? Do you say, is the person able to use the product? Do you say it's available? Add-ins are not working. Does that make the whole product not fully usable? If you had metrics on the server side, would the telemetry show you that there was a problem? In this particular incident, it turns out that it took a little bit longer for the team to detect it compared to when the user started to run it. For one, the impact was not immediate. It took slowly as the add-ins were checking for the day. That's when things started to slowly leak. And also the metrics on the server side didn't quickly show that there was a problem on the client. That adds a new dimension overall on how you measure the quality of the product. That's one example. The second example is from my own world. YouTube is a top query for Bing. Everybody loves cats. They go to Bing, look for YouTube, go to YouTube, look for cats, and spend hours on it. On a typical day, you search for YouTube. You get youtube.com as the first, what we call an algo result in Bing, first algo. A bunch of deep links for people to go to specific places they want to go. There was a time in Bing, there was a team that was doing an A/B experiment. We do thousands of A/B experiments every day. And one of the experiments was experimenting in a way that had a bug, which meant that when people search for YouTube, this is what they got. Not youtube.com, something that's not very helpful. During this time, the chart on the right side is the availability for the product. Everything looks pretty much flat, right? There's small variations, but that's daily. Some variations that you say. The product, from our metrics perspective, looked to be a good product. Things are working well. But what would a user say? They would say, this product is not helpful. It's not working. Because for them, the availability of Bing in this case doesn't mean you go to Bing, get some random result. That doesn't really help them. They want to get to YouTube to watch those cat videos. That's the destination. That's what people want to do. The chart is, I'll maybe take a minute to explain the chart. The blue line at the top is the availability as measured from our server side. The black lines below is the traffic volume for a specific segment, which was the lower ones are on weekends. Weekdays, you have more traffic, and the red bars are the errors that you would see at the time. They're on completely different time scale. Otherwise, I wouldn't have a job if we had so many errors. But the point is that we do have some errors. This incident showed us there's a gap in our metric. We worked on improving it. That's how it works. There was another incident where it was not the query YouTube. There was another experiment during the incident. We didn't show any algo results or web results. The page had only ads. What did that mean? Bing and products like us, search engines, run on ads revenue. You show ads, people click on ads, we make a lot of money. But what happens after that? People will not come back to your product anymore, right? So that was another incident where it didn't look like a failure because it was a successful response. We showed results, but the results were just ads. If we just went down that path, we would look like this in the future. Do people remember this page? It's called the $1 million homepage, where every pixel on the page was auctioned off. One person actually ended up making more than $1 million selling this. Anyway, out of curiosity, I loaded this on all the browsers I have, including every ad blocker. Almost every ad on this page stayed. None of the blockers block these ads, so that's an interesting one. So let's get back to basics of what is availability and how do we measure and why do we care about. Are people familiar with this chart? Raise of hands. I just want to get a sense. Yep. You have the leftmost column, which shows you the percentage of availability, different nines. And there are 4 columns which shows you the number of minutes that you're not available or your outage minutes. And there's a super simple formula on the right side, which is you take the failures that you see and subtract that from the total request and divide that by the total number of requests, and you get your availability. Pretty simple, right? But the thing is, even though the formula is pretty simple and straightforward, a number of things can go wrong if you don't pay attention to what a failure really is. Or did you think of all the things when you think of request? When you look at all these availability numbers, what do you think is a good availability number for a given service? Some guesses? 3 nines, 4 nines? Depends. Okay, that's a good answer. Depends. It completely depends on your product. You can go crazy and try to build as many nines as you want, or you could not even have a 9 and say it could still be okay. It depends on your product and the scenario, business on what the expectation from the customers are and what your business expects. One additional thing that I want to call out usually when I show this chart is the 4 columns, when it says downtime per week, it can be misleading at times. For example, when you see something like 3 nines, it shows you how many minutes you're down for a day. It doesn't have to be a complete chunk of few minutes being down. As you're looking through failures that can leak throughout the day, let's say your service is running at 10, like a simple service that only has 10 requests per second, and if you're leaking 1 request every second, then slowly you will add up those failures, and overall, even though you are not down completely at any part of the time, you'll be running at a really poor availability for the day. So that's something to keep in mind. Let's go through an example. This is a parking meter. I'm sure anybody who has driven cars and tried to park and pay for it, has the parking meter. This is a solar-powered one, so there's an additional layer of failure that can be introduced. I read up on this particular image. It turns out it has a backup, which is battery-powered in case it's like Seattle, where it doesn't really, we don't have much sun. Anyway, so for a service like this, what do you think is the right availability? If you're just trying to figure out, ping the server and check if it's time to charge people, how much time has elapsed, those kind of things. There are a number of variables here. One is typically some of these, this particular one is used on weekdays, so you don't really need to run the service over the weekend, or if it fails during the weekends, does it really matter? Should it matter? That's one thing to think about. Work hours, so if the service has a problem at 10 p.m., should you care as much or should you not? Are there times when you should work on? For a service like that, is it 2 nines or 3 nines? Is that good enough? It depends. If you ask the city who's trying to collect the money, they'll want it to be available all the time. If you're the one who's parking, you don't care if it works or not, right? So it depends on the user who is thinking of the availability. One other thing that I've seen some services, some websites, even some of the prominent websites talk about is scheduled maintenance. I personally am completely against that concept, but there's reasons why I can see companies might want to use scheduled maintenance, but some people do take out that time in their availability metrics. I do think it's kind of cheating, but it depends on your scenario and how you measure your availability. Another example now, not a parking meter. I went to the FAA side. This is the US government, which tells you how many flights they manage on a daily basis. A lot of us have flown today, so I thought it's a good time to look at availability of flights. 44,000 is not a number I like, not easy to do math. So I looked up online, and it said 100,000 flights a day. So that's an easier number to do the math. So let's stick to that number. So if you had 3 nines, that means you have 100 failures a day. It depends on the failure. Some might be that the TV screen that shows you the movies or entertainment might not be working. That's not a critical error. And some failures could be engine failures, which could be a lot more catastrophic. Depends on how you measure. 3 nines, while 3 nines sounded good for a parking meter, it's clearly not good for a flight. 5 nines gives you 1 failure a day. That's still too many when you're thinking of people traveling on a flight that you would want it to be much higher availability. Let's add a lot more nines. This number starts to look better. Like, 0.01. Well, it doesn't sound as bad, but if you think of a year, that adds to more than 3 failures per year. We see far less than that when you think of the airline industry. So depending on the scenario you're talking about, the number of nines you want would vary completely. In fact, for a system like this, it's probably better to just look at the error number rather than the number of nines, because that helps you set targets and being able to monitor real impact for users. That's something I would look into. Then there is a issue with the availability coming down when the slides got copied over. Let's continue with this. So if you go to Bing, I work in Bing. We've been working on availability. If you ask me, how do you measure availability, I'll go through how we do and try to do it in a simple, in the allocated time I have. Going back to our formula, we talked about recap, total minus failures, divide by totals. We had 2 approaches we could have taken when we started. One was, let's go with 3 nines, 4, 5. Given the same definition of the formula we had, go very deep and eliminate every failure we had and continue to improve availability. The other approach was, let's actually redefine what total and failure mean, and over time, improve those things. And we talk about these metrics for availability. There are a number of versions that we drew. Some are real time, which within seconds we'll know the availability number. There are things which take few minutes, near real-time pipelines, and things which take few hours, which have the full fidelity, complete logs, remove bots, and remove all these other things, and that's another official metric we look at when we report out to our partners to say how well did we do. So this chart here has a lot of data there. Let me just try to explain how this works. At the bottom scale, on the leftmost side, you can see is like system level issues. As you go to the right, those I would say are the user facing issues. When we started, like any service a long time ago, we primarily looked at HTTP errors. Hey, did we get a success or a failure? Then you look at, oh, are you available or not? And then when you look at things like HTTP 400, there are a bunch of bad requests that come in. Do you really want to count that against your service or not? And then you start to look at, okay, 500 level errors. Those are really errors that happen due to your services or your infrastructure. Then we say, we have this concept of error pages within Bing, where we say, oh, the user was presented an error page, in which case we were able to gracefully handle. It's not really graceful, we showed an error, but in that moment, it's not as bad as it can be. We show an error page to the user. But then that's what we started to count. At some point, we had an incident where Bing was perfectly available, but for a particular set of users that were coming through an ISP in a region, the product was extremely slow. It was taking a few seconds for the product to work. Would you say the product is working or not? That's when we added this metric, updated this metric to say, if the product is very slow, we consider that to be unusable. That should count against the availability of the product. We said, at n seconds, we consider that a failure. Even though users got it, some people might have the patience to wait for the page and look at it, we consider that a failure. Then we go into no results. There's a time when you search for something, you search for YouTube, you get the results, but if you search for something complex, you may not get the results. I have a star there because in the first version where we just, hey, no results are a failure. We should just count against our availability. But then we have all these bots, which query us for crazy things that don't exist in the world. And nobody should be querying for those things. That was counting against our availability. Then we said, okay, let's refine what no results really mean. Let's come up with this concept of golden set to look at, hey, let's look at the last week or last day, and then look at billions of these queries that come in. And if we ever returned a result for this query, that means that they're likely good results because we know how to serve results. And if any of those queries start to not return results, that's a failure because we know we were able to return results in the past. We are no longer able to return it, that's a failure. That's redefining what no results. That's another evolution to the availability metric that was done. The next one is no algo pages. So this is the example I gave earlier where there was a brief period for a set of users, we just showed only ads. While we made a little bit extra money during those few minutes, that's considered a failure by us. Now, if we don't show the algo results, we consider that a failure because it really is not satisfying the user intent. That's considered. So these are some examples of things that have changed over time. What it tells you is that the metric is not a constant thing. Over time, as you run into issues, incidents, you update your metric. You find ways to refine it, improve it, so that it reflects the user's experience in a way that it should be. Now we look at the total traffic. I've used 4 examples here. The first one is measuring at our origin. You look at the requests that are coming in, well, it's all good. But there are a number of cases where your CDN might have connectivity problem to origin. If you're just measuring at your origin, users may not even be able to get to you, and then you would think everything is fine. That's another thing. Then how do we reconcile that? And there are times when, whether it's a DNS issue or whether it's network connectivity issue or a certificate issue where the users may not be able to get response from your service, then traffic cannot even reach your CDN. That's a failure as well. That's another thing we started to improve. So the denominator, which is the total, kept increasing. Because now you're looking at, and also the failures kept increasing, then the availability is closer to what the users would do. And the last one, which we did a few months ago, is this network error logging. The Chromium browser has implemented this network error logging library. It's a fantastic system where from the browser you can get telemetry on network level errors, whether it's a DNS error or TCP errors, or if you're running into certificate issues, you can catalog them, look at the data, analyze them. So that gives you a wide range of issues that people might be running into that you might be blind to in the past. That's another thing we've started to look at. These are some examples. One way we do is we also look at day over day, week over week volume projection to look at what traffic you might be losing. That, oh, looks like there's a fewer number of requests coming in. That's one way. We use anomaly detection to really figure out if we were to see traffic patterns change. That's another way. And also having monitors that could be synthetic or outside in can help you also to look at, are you missing something that really should be coming to you? Then, as I go through these things, some of these topics that I talked about earlier, how many nines do you want to have in your service? It's guided by what your business needs. For some businesses, it might be okay to not have many nines. And also depends on user behavior. If you go to a website, trying to look for scores, right now the World Cup is going on, whether you're following the women's soccer World Cup or the cricket World Cup, which India is going to win. Whichever you want to use, you need to look at, looks like the Kiwi in front is arguing with me that it's not going to happen, but we'll see how it goes. So users might be okay just refreshing the page if the results don't refresh immediately. The expectation is that, hey, once in a while, the internet has issues. If you don't see the latest result, refresh, things that might be okay. You don't have to make it perfect. But there are some services like the flight scenario where I talked about, the expectations are a lot higher than you would want it to be. Where and how you measure matters a lot. Where as in, is it happening at your service level, or is it happening from the user level where the user traffic is coming in? Along the way, there's a number of things that can make your service fail. That's another thing. And how you measure it. Are you doing synthetic monitoring? Are you doing log-based? Are you using a near real-time streaming kind of metrics? That does vary, because that can introduce issues of its own into this. The other one is the client-side issues. As we build complex systems, there are a number of cases where the number of clients that people have been using over time is going insane. People are, the days of pretty much everybody having a phone and using their devices is very common now. And people move between networks often. They're traveling. People are on super fast networks and on low-speed networks, intermittent networks, or even in a building like this, when I was connecting to the Wi-Fi here, it said super fast or something for the Wi-Fi connection. And it was even fast through my VPN as well, so it was impressive. But then if you get into the elevator, there's going to be some blind spots where you may not have good connectivity. So those kind of issues, do you handle them? Do you get to know when your clients are running into a problem, they can't reach you? That's another thing. And metrics need to evolve over time. One of the things I talked about in our thing, when you start early on, as you run into every incident, one of the things that Tanner and team covered earlier as part of the postmortem is learning from your outages and issues. Every time we have an issue, one of the things that we first do is go look at our metrics. Did our metrics reflect the bad thing that happened? If it didn't reflect, it's a bug. We need to fix our metrics so it really represents what problems users ran into, and it's a true representation of user experience. Outages and failures can affect your metrics. In almost all systems, the pipelines that do the telemetry and the product share the same network, same systems. A lot of times, it's expensive to have redundant systems for many of these things. So if you have an outage because of network connectivity, the system that's sending logs or samples through your streaming pipeline might not even be getting the systems, because you may not, the same thing that was causing a problem for your product might also be affecting your telemetry pipeline. So having a reliable telemetry pipeline is important, even if that means retry mechanisms, something that can send the data offline as things are back. That's another thing to look at. I was going through the program list for the conference. I saw a couple of talks that talked about some of these things. One was about business metrics, why it's important, not just looking at the user level metrics that were service-based. And the other one is about practical instrumentation. How do you look at the telemetry pipelines and how do you make that reliable? Those two seem relevant. I would recommend taking a look at it if you get a chance. And then it looks like I have about 2 minutes. If you have any questions, I can take them. Maybe time for one question. Okay, thanks.